So my report, the project that I did was an assessment of the post-fire vegetation recovery in Washington State using Landsat and geographical data. And this presentation will go over the objectives of this project, the data and methods used, regression modeling, results, and then finally the conclusion. So for the objective of this project, I wanted to look into whether environmental variables have influence on vegetation regeneration. And to do this, I was going to look into NDVI over time to see about vegetation changes, and then also to perform regression, both exploratory and then weighted regression. So the study was done in Washington State, and I chose 6 areas located primarily in central Washington as well as eastern. The burn times were the summers of both 2013 and 2014. So there was a number of different data sets used to accomplish this, the objective. The first one was Landsat images. I downloaded images from pre-fire, post-fire, and then every year for the next 5 years, again, to look at them over time. And these were used to calculate the NDVI, which is the normalized difference vegetation index. And this was calculated using the near infrared and the red bands. And this was to look at the greenness of the site, the plant index. The next type of data was the 2011 national land cover data. The year was chosen because it would have been pre-burn. And I tried to get a different mix of vegetation. So cottonwood and watermelon burn areas were primarily desert. So they consisted of shrubs and grasslands. And then Upper Falls and mile marker 28 were primarily forest. And then Snag Canyon and Devil's Elbow were kind of a mix of the both. And in order to use this data in regression, I needed to convert the categorical data into a Boolean layer, a dummy variable. And this was done through R and through the layerize function to make it into a Boolean. And again, this was done for all vegetation types over all study areas. Next data was the digital elevation model. This was used for elevation, but also to calculate topographical variables, aspect and slope. And there was a difference of elevation. The Cottonwood had the lowest at 350 meters, and Upper Falls had the high end of the spectrum of elevation at not quite 2,300 meters. And then the last data set was the normalized burn ratio. This was downloaded from USGS. But they derived this through looking at the near infrared and the shortwave infrared of both the pre and post images of a fire, pre-fire and post-fire. And then they differenced those images to look at how much really burned. And so you could see the differences of the burned areas in this slide. So the light green color is low burn, which Cottonwood is definitely on the lower end, whereas Upper Falls is mostly red, which is much higher burn area. So with these data sets, they were all projected into UTM 10 and or 11 based on where they were in Washington, clipped to the burn area, and then converted to point data. From there, created a 30-meter fishnet vector, and that I took the data points and then spatially joined them to the fishnet. So it ended up with one vector consisting of all the data sets, as you can see in the snippet on the bottom. And this was all done, that whole part from the last slide was done through Model Builder. This is the first part of that, which is the clipping, the projecting, and then making them into point data. The follow-up step from this was a much simpler model that just spatially joined them to the fishnet. Now that we have all of our data, I performed regression modeling. The first way was using exploratory ordinarily least squares regression, where the NDVI year 5, so the last year of regeneration, would be the dependent variable, and then the explanatory variables would be the post-fire NDVI, the difference, normalized burn ratio, elevation, slope aspect, and then the Boolean layers for the land cover. Based on the exploratory regression, then performed weighted regression. And I chose to try 4 different models for each of the areas to determine kind of the best model. I tried the Euclidean distance, 8 and 30 nearest neighbors, and then also AIC optimization. So the results of all this, the first part of it was just looking at regeneration of the vegetation over time. And I did that through a box and whisker plot and divided it according to the vegetation type, the land cover type. So the first green box is the forested vegetation, and you can definitely see a drop off in NDVI values, but then very inconsistent results for the next 5 years. Desert vegetation is similar. Definitely less of a die-off, definitely less of a value change, but then a very sporadic values over the next few years. The mixed vegetation had most consistent. It dropped off and then slowly increased over time. So the results of the exploratory regression resulted in high collinearity for land cover with other land cover factors, and all variables were positively autocorrelated. Burn severity, topographical, and then the post-fire NDVI were all major players in all the models. So based on the exploratory regression, I worked on the weighted regression in which land cover was not included because of the collinearity, but also because the dummy variables can kind of skew the results of weighted regression. The models all ended up being 8 nearest neighbors, except for Cottonwood, that ended up being 30 nearest neighbors for model type. And then there was definitely an increase in R-square values over the exploratory OLS, but as there are disproportionate amount of information for each observation, it's not really a good indicator of fitness. So I was looking into the residuals. Most of them were very similar. They hovered between 0.5 and 1, except for mile marker 28. That burn area definitely had the highest residual values. And that can be seen in this slide. So this is the standard residuals. Overall, the standard residuals ranged between about -10 and 12, which is definitely shows a big difference between predicted and observed. But the mean values all hovered right around 0. So between, I think it was 0 to 0.38 was about the average for all of them. And then as a conclusion, to go back to the objective, which was to determine whether environmental variables have an influence on vegetation regeneration. This study showed a positive relationship between burn severity, topographical variables, and the regeneration. But also vegetation type had a big influence on regeneration as well. And then for future studies, I would definitely include additional variables into the model, such as climate, like precipitation, including different specific vegetation types. I think that would be important. And then of course, seeing it on the ground and where it is and how it's situated would be very important. And that is all.